Hello students, in this video we are going to study about conductivity of solids, chapter 1, class 12 chemistry. इसमें हम पढ़ेंगे कंडक्टिविटी ऑफ सॉलिड्स. कंडक्टिविटी के बेस पर बिफोर आई स्टार्ट let me request you to please subscribe to my channel and see the video till the end so that you don't miss any important thing. सॉलिड कंडक्टिविटी के बेस पे सॉलिड्स को हम तीन पार्ट्स में डिवाइड करते हैं मेनली. वन इज़ कंडक्टर, सेकेंड इज इंसुलेटर एंड द थर्ड इज सेमी कंडक्टर्स. So we differentiate between the three types of solids. Conductors are the solids in which electricity passes through. There is easy flow of electrons. Easy flow of electrons. इलेक्ट्रॉन्स जो हैं कंडक्टर्स में फ्लो करते हैं एंड इनका एग्जांपल जो है वो है मेटल लाइक गोल्ड, सिल्वर, कॉपर, आयरन. दीज आर द कंडक्टर्स. इनमें जो है इलेक्ट्रॉन्स कैन पास थ्रू एंड वी से दैट इलेक्ट्रिसिटी इज पासिंग थ्रू द सॉलिड्स एंड दे आर कॉल्ड कंडक्टर्स. इनकी अगर हम कंडक्टिविटी देखें तो दैट इज़ वेरी हाई कंडक्टिविटी टू द रेंज ऑफ 10 raised to the power 4 to 10 raised to the power 7 ohm inverse and meter inverse. See, this is the unit. See, conductivity is the reciprocal of resistivity and resistivity unit is ohm meter. So the conductivity is ohm minus 1 meter minus 1. Now valency, generally the metals have valency less than 4. Valency of less than 4 so that the electrons can transfer from valency band to the conduction band. Valency is less than 4 and if we see the energy gap between valency band and conduction band, that is very small, very small, so that see, this is the, if diagrammatically हमने डायग्राम से ये बताया है कि दिस इज देयर इज नो गैप, एनर्जी गैप बिटवीन वैलेंसी बैंड, partially filled valency band and conduction band. There is no gap, no energy barrier, and here it is overlapping. Even valency band or conduction band जो है, they are overlapping each other. And this is graphical method of representing this. And in case of insulators, by definition we say that there is no flow of electrons or any charged particle. When there is no flow of electrons or any charged particles like ions, then we say that these solids are insulators, and example is air, rubber, plastic, mica, wood, etc. And its conductivity is 10 raised, see how low is this, 10 raised to the power minus 20 to 10 raised to the power minus 10 ohm inverse meter inverse. And its valency is generally greater than 4 if we see valency, and in energy gap it is very large to the tune of 15 electron volt. Means if we can give the particle 15 electron volt of energy, then it can move. But this is very high amount of energy, and so the at this remains insulators and no flow of electrons, no flow of electricity. You see, in diagrammatically we can show it by the showing that EB, barrier energy, is very much high. Forbidden energy gap, here this is energy and these are insulator substances, then forbidden energy gap is very much high. And now the third category is semiconductors. Here semiconductors, the example is silicon, germanium, arsenide, etc. And its conductivity is 10 raised to the power minus 6 to 10 raised to the power 4 ohm inverse meter inverse. And its valency is equal to 4. Generally it is equal to 4. And its EB, barrier energy, is small, with small energy gap to the tune of 1 electron volt. So by giving this much of energy, the semiconductors start passing electricity, and without giving the energy they don't pass electricity. So there is moderate flow of charged particles in semiconductors. And you see, the solids conductivity जो है टेम्परेचर पे भी डिपेंड करती है. कंडक्टिविटी राइजेज एज द टेम्परेचर इज increase, because higher the temperature, more will be the energy of the moving particles. Hence electricity is also, conductivity also increases with temperature. In semiconductors, the conductivity can be increased. Conductivity can be increased. How? By adding impurities. If we add impurity to the semiconductors, the conductivity is increased. Because semiconductors have conductivity which is very low, and that is not of any practical use. So to use it practically at a desired level, what we do, we add impurities, and this process is called doping. This process is called doping. Now, silicon and germanium, these are the two semiconductors. They are on 14 periodic table. They are placed in 14th group. Now, there are two methods to increase the conductivity, or there are two methods to increase the conductivity, and there are two methods for doping. One is two methods of doping. Number one, by adding electron rich impurities, and second is by adding electron deficit impurities. You know that silicon and germanium are 14th group elements, and they have valency as 4. They have 4 valency electrons, and if we add the impurities of impurity and element, if we take impurity element, अगर हम 15th ग्रुप का ले लें, 15th ग्रुप का फास्फोरस और आर्सेनाइड, देन व्हाट हैपन्स, इनकी वैलेंसी होती है 5. दे आर इलेक्ट्रॉन रिच एलिमेंट्स. वैलेंसी इलेक्ट्रॉन्स जो हैं वो 5 होते हैं. तो इसमें क्या होता है कि जो ये 5 इलेक्ट्रॉन हैं, 4 तो कोवलेंट बॉन्ड बना देते हैं. 4 इलेक्ट्रॉन्स दे मेक कोवलेंट bonds with the atoms of silicon and germanium, whatever the basic substance is. 4 इलेक्ट्रॉन्स आर कोवलेंट बॉन्ड बन जाते हैं. एक इलेक्ट्रॉन जो है फिफ्थ इलेक्ट्रॉन is extra, and it delocalized so this electron is the reason for increases the conductivity. See, if there are, say, silicon atoms and one atom of phosphorus is added, then what will happen? See, here every has 4 covalent bonds. Here it has 4 covalent bonds with the this is silicon plus 4 plus 4 plus 4 plus 4 plus 4. This is plus 5 valency. This is 4, this is 4, this is 4. So one electron, this electron, because 4 इलेक्ट्रॉन 4 इलेक्ट्रॉन से तो कोवलेंट बॉन्ड बन गए, और बाकी जो 5th इलेक्ट्रॉन है दैट इज फ्री इलेक्ट्रॉन available for moving in the crystal, in the solid, and hence the conductivity increases. Now we come on to by adding electron deficit impurities. अगर 14th ग्रुप के सिलिकॉन या जर्मेनियम में हम 13th ग्रुप के बोरोन, एल्यूमिनियम या गैलियम इनकी डोपिंग कर दें तो क्या होता है? बिकॉज दीज आर टेट्रावेलेंट, वैलेंसी इज 4, बट दीज आर ट्राइवेलेंट, वैलेंसी इज 3 13th ग्रुप की. तो व्हाट हैपन्स कि जो 3 इलेक्ट्रॉन है सिलिकॉन के, 3 इलेक्ट्रॉन्स ऑफ सिलिकॉन, दे मेक कोवलेंट बॉन्ड्स with बोरोन, बट एक इलेक्ट्रॉन जो है, one electron of silicon will not be paired, and in that place one hole will be created. One hole will be created. How? Let us see. ये बोरोन है, बाकी सिलिकॉन है. सबके 4 कोवलेंट बॉन्ड है क्योंकि 4 वैलेंसी हैं. बट इन दिस केस दिस हैज बोरोन हैज ओनली 3, तो 3 कोवलेंट बॉन्ड बन गए. But here silicon has 1 electron and boron does not have any electron, then this will be this will be a hole. Hole will be, this is called electron hole. As the electron hole, how it will be filled? The neighboring atom electron from the nearby atom, it will fill this hole. One electron from nearby atom of silicon will fill this hole and leave behind a new hole in its own place. जो एटम इसमें अपना इलेक्ट्रॉन देगा इलेक्ट्रॉन होल को फिल करने के लिए, उस एटम के अपने प्लेस पे, अपने जगह एक इलेक्ट्रॉन होल क्रिएट हो जाएगा. तो इफ इलेक्ट्रॉन इज मूविंग इन दिस डायरेक्शन, देन द होल विल मूव इन दिस डायरेक्शन, opposite to the movement of electron. So this is how the conductivity takes place in this type, by adding electron deficit impurities. Now adding of electron rich impurities in first case, because there the doping element is electron rich, means negatively charged, so this is called n type semiconductors. And in second method, when we add electron deficit impurities, positive holes are created, and we say that it is p type semiconductors. It is the movement of holes that takes place, and conductivity increases. Here let me tell you that what is the effect of doping. Effect of doping on semiconductors. अगर पहले इनका जो एनर्जी बैरियर था that was equal to 1.12 इलेक्ट्रॉन वोल्ट. सिलिकॉन का इलेक्ट्रॉन बैरियर 1.12 इलेक्ट्रॉन वोल्ट है. आफ्टर डोपिंग with phosphorus or arsenic, its energy barrier becomes 0.045 electron volt. So अब ये पता चलता है कि एनर्जी बैरियर इतना कम हो गया आफ्टर डोपिंग विद दिस डोपिंग एलिमेंट्स, तो इसलिए वी से दैट conductivity of semiconductor increases with doping. And इसमें इतना ज़्यादा फ़र्क आ गया कि पहले 1.12 इलेक्ट्रॉन वोल्ट इलेक्ट्रॉन को देनी पड़ती थी ताकि वो वैलेंसी बैंड से कंडक्शन बैंड में आ जाए। अब सिर्फ 0.05 इलेक्ट्रॉन वोल्ट देनी है आफ्टर डॉपिंग कि वो वैलेंसी से कंडक्शन बैंड में चले जाए, तो इसलिए कंडक्टिविटी इंक्रीजेस। नाउ बिफोर आई फिनिश दिस lecture, I will again request you to please subscribe to my channel. Thank you.